Check the name you see. Double check your name you see. Is it? Okay, good. Good.
So today, what do you do? Continue with stage 1 lah, but new project lah. Okay, that is analog. Okay, then we learn compare function. Okay, and we do SCADA in our backlog. Okay, so for that we will be using the global team. Okay, global team. Yeah. Okay, so what you do, you create a new project. For lesson. put the name compact. You add your module. That's okay. Then you go to name.
No,
Okay.
hello.
Allow is in the middle. Then you add C, compact, okay. So you see what is compact? Comparison,
Nak tahu lah.
no, SCC. Compact is comparison, compared to data. Okay. So it will compare, then it will give you a output. Okay, we try a few compare. So what you do, take the equal, right? Okay. Can you see? It's like normally open, right? So compare is actually like a normally open function. Okay. So inside, you double click the inside one, yes. This one to choose what is your data type. Okay, whether it's integer or real or double integer, or so many. You can compare time, character, all that. Okay. Let's say we choose integer. Okay. Then here on top, because we haven't done any scaling yet, right? Okay. So what we do, let's say you just put it memory like MW0. Okay. Then below MW2. Okay, rename data 1, data 2. Okay, then you add the output Q0.0. Then you leave it the name as, let's say, output 1 or LED 1. Okay. Then we add another one below here also. Okay. Compare more than equal. Yeah. Greater than. Okay. So inside here maybe we use real. Okay. So if real must use MD, right? So MD berapa? Again use MD4. Okay. And below, okay, not necessarily memory. We can put constant number also. Like let's say 75 degree. You want to, then just put 75. Yes. Okay. So this one we name it as rename to data. Okay, then the output LED 2. tu tapi ada address, right? Actually, you can key in address, lepas tu can rename, or you can put the name, later can define. Right click, new, define tag. So it's apa actually? It's not a memory, right? So you choose here, yeah. Type Q0.1. Like this also can do. Okay. We can put name, later can define also can. Okay. Okay. This one is I compare, I energize. Then I compare, I energize. So we try another one, that is I compare, I cut off. Okay. Go down. So I compare, I cut off means someone need to on first. Right. So what do? You put your push button. So I0.0. You create a normal program. Start stop. Start stop something. I0.0. Sheet. Okay. So means I create output, right? So it means I want to compare and I want to off. And okay, so what you can do, you click here, you add a branch. Okay, you add a compare, maybe greater than yang ni. This one. Okay. Drag over here. Integer maybe. Okay, so I want to use NW. NW, what I can use? Yes, put NW8. Okay. Below you put some constant number. Let's say 50. Okay. Then you right click here. Ini just now data 1, data 2, data 3, data 4. Okay. Alright. You see, you go up. Okay. This one, I compare, I on something. And okay. So in front, I can put interlock light. And okay, maybe when the valve is on, I compare. Once the comparison done, then I can on out. Okay. So because this comparison is like a normally open with condition. It's not cannot be normally closed. So normally open with condition. The condition is data 1 must be equal to data 2. Then I energize this line. If not equal, I cut off the line. Okay. Go down next one. This one is same. So the condition is the data 3 must be greater or equal to 75. Then I energize this. But in this case, what I want to do, let's say I start, something is on. Okay. Then I compare the data for greater than 50. I want to off this one. So of course this is normally open, right? I cannot put here straight away. And so what I do, I create like this and I create a memory. Click here. You add a output. Okay, like like the timer. After the timer, we create the memory. Then we use to cut off, right? The same concept. So what memory I can use? Berapa? No, this is a boolean one. 0.0 can use because you already use MW0. So you see, it's simple. Okay, next I want to use boolean. Next number is what available? 10. So M10.0. Okay, you right click. So just put off LED 3. Change. Okay. Then you use this memory to off this one. Yes. Okay. So now I create the program in FC. This one we call subroutine. Right? So what do we need to do?
Right to the main.
Yes, you open the main. Okay, you add here. Okay. Save. Okay. So later we do a block, we do SCADA, we do training. Okay. Now save, we download, we test first. Okay, then we go to the this one close. When you see this one on right, because the other one, the other is same lah. Okay, we double click here. Can hit any number. Okay, so now it's not equal is
Do I need to download the hardware?
hardware no need actually.
Because my MW0 have data from my injector.
Okay, good. We see why. You don't move. You don't move, huh? Okay, go down. Go down. It's not from the injector. It won't be. Okay, go up. Okay. Interesting. it because of injector is that clashing, the value is clashing somewhere.
It's a new project.
Yeah, no, it's a new project. Of course, it will erase the MW value. Okay. Even though because you didn't download that, you create new project, you download, right?
Create new project and download the reference. Yes.
Right. So it will always clear everything and download.
But not the hardware.
Hardware also download.
Oh.
Hardware also download. Okay. But now, because this one is now the number is like this, right? Because it means that the MW somewhere the MW is like on off something. Okay. One. Go to main. Go to main. Go to compact. Go down. What's the M? Not using anywhere like the M0.0, 0.1, right? T. Okay, you go offline. Okay, right click here. Okay, don't download. Go to properties. I think this one is because of your this one. This one is flashing. Okay. I mean the previous one because yesterday we enabled this correct. Because whenever I create new project, it will download the program and also the hardware. But it will download hardware means it's not like download the whole hardware. No. Just hardware. Okay, what are the hardware you added? So the settings all you need to download it if you want. If you're changing that, right? You click, you enable this, and you put 1000. Okay, then this one is. Oh, no, same 1001. Okay. Download. Okay. Then you right click, download the hardware. That's okay. Can I? Send it. Okay, what?
This side.
Right. But okay, wait now. You go down. Whenever you go down, like it. So whenever you have the name like this, right? So what you can do? Just go to the PLC tag. No, go to PLC tag. Yes. Show all tags. Okay, you check here. Where you have, data form. MW8 is data form. Next bar here. Data 1, data 2, data 3 kan? So this should be data form. The name sebab tu ada the bracket. Okay. Save download. Now okay. It's okay.
Okay, but I have another alarm. Difference in lower level component.
Okay. Because you need to download the program. Okay. Monitor. But it shows different in lower level component. What is that? And actually, because when you add just now the memory, kan, so it add the always on, always off, the pulse, all the memory, all the tag added here. So it shows lower level component means here. It's a difference.
The first time I download, don't have this thing.
Yeah, don't have this thing.
Now have, and then it's clashing like that.
Not clashing. No, not clashing actually. Okay, wait, okay, first time you download the program, and program hardware digital. Then you go to the PLC, you enable these memories, right? Then you download the hardware configuration. So hardware is okay. The program, your program is okay. So the moment you enable these, all these added in your tag table. So you only download the hardware component. Program need to re-download.
Because the program inside the PLC don't have this thing.
Don't have this particular. But even don't have also no problem. Why? Because this one we are not using yet. So it's still okay. But that is the meaning of this one, the lower level component. This is what here. From here means always like this one. Even there is different in here also same thing. If you show the lower level component means below. There's a difference below. So here, but it won't show where is the difference. Normally it will show like this. If the program is different, then only it will show like the orange, half orange, half blue. Yes. If there is a difference in the PLC tags, I won't show it. Okay, so just download the program. Actually, you can right click the PLC tag, download to device, software only changes. Also
Only changes.
Go up, go to your computer. Okay.
Cannot find the
Why cannot?
error.
Error.
My data is green.
Not the issue. Okay, go offline. We see why extra. This is integer, right? Go to show all tag. Can you see all these invert? And change to integer. You know why they become so yours others all okay, right? You know why? Because when we select the compare, when we select the compare, and so they are greater than this, then they are keluar question mark, right? So if I key in, if let's say I didn't choose this one, and if I key MW0, so MW is a word. So here, because this one don't have any data type to follow, so they can automatically jadi word. Let's say I add here, then after that I add here make it integer, for example. So when I key in here, this one become integer because it follow this. Earlier don't have. So that's why I think before you choose the integer, you already key MW0, MW2. That's why it become a word. Okay. Alright. Now monitor. Okay, now what can you escape? Double click on the number, yes. And okay, measure. because it's an equal, right? Okay. Yes. Okay. But now, for now, we manually key in lah, right? Go up. No, go up. We manually key in lah because we don't have any project yet. If actual project, maybe this one is from your analog. And because you see, what is the purpose we do scaling actually?
To learn how to use analog.
No. Actually, we have the value, right? Very simple. You see, at IW64, I get 0 to 27648. Okay. Why we do scaling actually? Why we convert this one into a temperature, let's say MW10, okay. The temperature value 0 to 150 degrees. Okay. Why? Number one, we want to show in the HMI and temperature value lah. Okay. Number two is using for comparison. Only these two only we use. Other than that, why we want to do scaling? No need, right? So, I want to show in the HMI. I can show this number. Nobody will understand. Okay, so I have to convert this number into the depend on the device lah. So I can show in the HMI. Or I use for comparison. For example, after I compare, okay, let's say greater lah, okay, greater than integer MW10, okay, 50 degrees on a alarm. So because at MW10, oh sorry, I would say after 75. So at MW10, I get the temperature value. So I compare with the temperature 75 is my set point. Then I on alarm. Let's say if I didn't do the scaling, can I use this to compare or not? Can also. Okay. What we need to know is 0 to 27 temperature, right? 150. Here 75 means up. So here how much? So here is 13,840 up. Okay. So 75 in temperature in analog is 13824. I can use this number also. Okay. Instead of using this compare, I can use this compare. It's the same thing. I use IW64. I use this number. And now I use 13824. Do some. Okay. One, because this is in temperature format, I put temperature. This is a raw value. I use the raw value. So can also. But so let's say that I have analog like this. Let's say the value like this, I don't want to show in the HMI. I just want to use for comparison. When it reaches certain value, okay, I want to on out or off out. So I notice convert also. I can directly use like this. But there is a problem. The problem is in the future. Let's say you check 75 is not enough. At 70 degree I want to on the alarm. So if the program is like this, so if another guy go in to do the modification, so it go in here, just change this to 70 degree. But let's say the program will do like this. What can it do? Can, but you need to calculate again. So you need to do in your formula, you need to calculate 70 means how much. Because you didn't do scaling one. So 70 means how much? Let's say for example 13,000. So I need to change 13,000. But if If in this format, easy to change. So that is the reason we do scaling actually. Actually, analog input very simple. Sometimes people thought analog is very difficult. No, analog programming very straightforward. Because the only two purpose. After I scale, I show in the HMI or I do comparison. That's all. Or maybe I do calculation lah. Okay. Even still the same thing. I calculate, I show in the HMI. Like yesterday we do, right? Yesterday's project. After we scale, we convert into a height. Then the height, we use the height to do a calculation to calculate the volume. So that is why they use the what? And so this one can. So this one, you see, if you want to on something, direct. You want to off something, okay, you make it 51 here. Yeah. Okay. Oh, you haven't add here this memory add here. Put here normally close. Here. Okay, normally close. Yeah, off LED 3. M10 point, no, it's a 10. 10.0. Okay, wait. Undo, just undo. Okay. If you put wrong address right, just undo. Because if you modify, so M10.02 will be added in the PLC tag. So then, so many tagging. Download. Okay. Monitor. Okay, you change to 50. Double click. Change to 50. Okay. Start. Press start. So let's say start some output lah. So on is running, then when the value this is your set point. Always, because compare you see one is top, one is bottom right. So top one is always the variable lah, always change. Below is always the set point. Okay, you change to 51. Okay, cut off. So if you want to cut off, this is the way. If you want to on something, you can use this way also can, the other way also. Okay? Any question? No question. I want to modify this thing.
Sir, we have a question.
Yes.
Input and output, input signal or analog and voltage. Ada yang mana yang akan effect dengan interference? Ada effect interference?
Yes, we effect.
Ada.
Yes. The values, I mean the normally analog lah, the milliamps.
Analog.
Milliamps kan.
So
Inputs.
So when you do the wiring, the wiring cannot cross the AC gap.
Yeah, normally because if high voltage AC. Yes. So if high voltage AC and in the panel lah, let's say high voltage AC, then our analog, if it is running on the same this one, right? So they can create noise. So what happen? Your value won't be stable.
Oh, wait a minute.
it will fluctuate. So let's say 75 degree at the so you're supposed to get 13824, right? So dia lebih kurang okay 138. Let's say the range is 13820 to 13830. Okay, so if there's no interference, right, there's no noise, so the fluctuation and is up and down slowly, be slow lah. Okay, of course like it won't be stable straight. Okay, because there's a small changes also you can detect. But if there's a noise, you can fluctuate high. So from 20 to 30, they can very fast fluctuate. Because of that and also of the cable, there's a lot of the cable, our what, terminal, and the knot, cable distance, all that. You need to take care of all this. If you don't want to fluctuate too high.
So for long distance wiring, which input you output prefer?
For long distance voltage.
Voltage.
Yes. Better voltage. Because you know why? Because voltage is run on 0 to 10 volt. Kalau milliamp 0 to 20, right? Kalau kita convert to voltage is like 0 to 5 volt. So lagi rendah.
So input and output sama, voltage
Sama.
for long distance.
For long distance. Or you can use like signal booster lah. So in long distance. Or that's where they use remote I/O. Like this remote I/O.
For booster, that means we need to add the extra power supply at the side.
Not extra power supply. Can use like the isolator. So let's say this is the one thing long. I mean very in a long place. So here is, let's say, the CPU. Here is your instrument. Okay. Then from instrument to the CPU is very long distance. Okay. So why are you want to put an isolator in the between? So from instrument go signal to the isolator. Then from the isolator you can go to the PLC. So the cable from here to here, and isolator can go to here. Or that's where they normally use remote I/O. So CPU will be here. Let's say most of the instrument is here. Okay, then they will put some remote I/O near to your instrument. So all the instrument will be connected to here. From here to my CPU, I am going to use a Profinet or Profibus. Profinet can go to 1000 meter plus. The distance. I mean one cable, yes. Profinet. 1000 meter. Oh. They put single Profinet. No, Profinet 100 meters, sorry. 100 meters. A single Profinet. Wait, let me confirm. Profinet is 100 meter lah. By using the Ethernet switches lah, right? From your device to the switch, 100 meters maximum. Then from the switch can be another 100 meters. Okay. But Profibus can go up to 1200 meter. Like one long cable can go up to 1200 meter, but at lower speed. So the higher the distance, the lower the speed. If it is shorter, like 100 meter, it can pass data 1.2 Mbps. If longer, it can only pass data 9.6 kbps. So sometimes the Profibus they use repeater. You can use repeater can go up to 10 km. From one device you want to take data, right? So in the between repeater can go up to 10 km. Or you can use a fiber optic also.
Fastest one.
Yeah, fastest. But you must use a converter because our PLC don't have fiber optic. So what you do, you must have a fiber, either Ethernet to fiber optic converter. So from here to the converter, then the fiber optic travel to the other place. Then there you must add a remote IO. Then from there fiber optic to Ethernet converter and connect. So last time I went to company provide training in ER, like a LRT. So they have this one is from KL Central to Milan. So we went there for do training because even train also using PLC, you know.
Yeah.
Train all using PLC. So what they do? They have a plant. In the plant they have a control room. So this is the station, right? And they have another station, right? Okay. In your PLC, in your train with the PLC, the station have the PLC. So when this PLC, when the train want to reach this station, station 1 example, so station 1 will send a signal to here. So but this one all using the servers. They're using like a servers, okay? Goes very far, you know, right? And because from one station to one station, right? 20 km plus, 20, 15 km plus, okay? So they use, because I go to the control room. They have a PLC, and last one they have a communication module. Send, you can see the name send receive. It's a send and receive transmit signals. Then this is the station. Then at the far, I think around 2 km plus, they have a like a train washing station. The washing. Okay. So that was also controlled by PLC. For that only they use the fiber optic. The PLC is here in the control room, but at the near the washing station they have a remote system, remote IO. So from here to that they control. They use the fiber optic. Because they bring me to show that more than 2 km. Okay, good. So now you know how to use the compare. So to on something, to off something, right? So compare, don't think compare is always this. Okay, compare is very simple. It is a normally open. You just treat the compare as a normally open. So it means not like this only. It can be in front, can be something. Okay, it can be like this also. Okay, normally open, normally close, then suddenly compare, then normally open. Then that's it. That's also okay. Don't think this one must be normally open. I mean compare that one output. This is just an interlock, similar to your normally open normally. Can be like this. Maybe less than some data. So here more than, here less than. Okay. So what we do? This one okay, but I want to use back the. I want to use back the start stop lah. So you can delete this all this. Okay. If this one is okay, you can delete this. We do a project. Here. Okay. Because I want to use back the same address. Or okay, if I don't want to disturb, what you do? Okay, you go down. Okay. You right click here, just empty space, rewire. Okay, the start and stop, you use some other address I0.2 and I0.3. 0.2 and I0.3. Yang stop. Yes, I0.3 means I use some other address. Change. Yes. Okay. Then
even will start.
name also we rename.
No, I mean the start one, the push button one. Also change the address.
Yeah, that's the one I want to change the address. No, I want to change the address for the name only.
For the name only.
Yeah. Earlier we using the start as a push button. Now the start I want to use as a this one. I want to rename the name also. You right click. Can do here. Easier. Where is it? You click here. You click on the address. Okay. So the start stop you change the name. Start LED. Just put start LED, stop LED. Okay. Then this one also I change the address Q0.3. So means I can just modify that, change some address so that I want to use the first push button, second push button, the lamp for my project, for the first lamp for my project. Okay. So when I do like this, I don't need to delete the compact. I can still use compact function. Okay. So later, if you want to use any memory, you use after 20 lah. Okay. Regarding the memory also, because you see some I do use M0, MW, some MB, some the Boolean, right? If whenever I do a project, what I do, I will allocate for myself. Because you see, memory, right? Memory, we have memory by 0 until memory by 40945. This much of byte I have. It's a byte, okay? Means I can use as a boolean or word, double word, and so on. So what I do, I will allocate. Okay, let's say from memory byte 0 until memory byte 9. I want to use for boolean only. It means each byte got 8, and here got how many bytes? 10 bytes. So I can use 80 booleans, which is M0.0 until M9.7. Total lah, 80 booleans I can use. Okay. Then what I do? Okay, I will allocate myself. Starting from MB10 until MB99, for example, right? Okay. All this I want to use as a word. So means I can start from MW10 until MW98, because 98, first, second, 98, 99. Then if double word, I will start from 100. can allocate it. Or I just go to like 10,900. Okay, almost there. So I can use mix like MW, this MW, or I can use MW or MD inside here. So I just, for me I just allocate. Even though here I only use 5 boolean, I can start with 10, 20, or I can all start with 100 above. For any values like for like this right, MW0 right, anything I start above 100. Below 100 I use for boolean. Also can, because I have 4,000 baht. That's for your model 1212 and 1211. If you go to model 1214, can go up to 8,000. 1214, 1215, 1217 can go up to 8,000 memories. If you're using 1,005, can go up to 32,000. So memory is very big. Okay, but why I ask you to do follow, right? So you can understand better. So when you do mistakes, you know why the problem is that. If the value clash, you can know why it's clash. Okay. Okay.
For LED 2 and 3, change the output.
No. So
LED1.
just leave it like 1, 2, 3. 1, 2, 3 is leave it on the LED. I mean, you mean the name?
No, the
address, right? Never mind. Leave it. Okay. Now what you do? Now you add below start stop. Okay, that is your I0.0. Enter. I0.0. The address I0.0. Okay, then stop. Okay, and compressor. Okay, compressor is your Q0.0. Okay, good. Okay, you see now, because this one all is in the same project, right? Okay, so this just now we already used the push buttons. That's why I just shift the buttons into different ones so that I can use the first push button, second push button, first line for my project. That's why there's no change. If you want to do a project that is compressor project, so you don't touch the compact. Okay, create a new one later. Okay. But the project, how the project works. This project will have a, of course I not be open or close normal lah. Okay. We'll have a compact and also scaling together. Okay. Because others all we do some projects, right? Okay. So we do scaling. Because yesterday scaling, we didn't do any project, right? I will issue. Now, very simple. Let's say I have a compressor. I want to maintain the pressure. I have a 2 set point. I want to maintain in between that. Okay. So I have a start button. I have a stop button. Let's say I have the compressor. So yeah, this one you have the address right, I0.0, I0.1, Q0.0. Okay. Now I need the current pressure. Okay, current pressure from where I get. what is the scaling? Let's say 0 to 27648. That is my AI channel 0, right? Compared to pressure. Okay, like yesterday in the picture we have how much is 0 to 250 millibar something. So let's say change to 250. Okay. So I will convert this, so that will be my current pressure. And now I have two set points. That is cut in pressure and cut off. My cut-in pressure is, let's say I want to maintain from 180 to 210, for example. Okay. So my cut-in pressure must be less than 180. My cut-off less or more or equal to 110. So below 130, compressor on. More than 210, compressor off. Okay, okay. So how the flow chart works? Okay, very simple. When I press start, okay, and I have two conditions. When I press start and the current, I put CP, current pressure must less than cut in. Maksudnya, when I press start, I make sure the pressure is less than 180. Then only I can start. I put this two comparison. Two conditions. First condition, when I start, at the same time, the current pressure must be less than cut in. I on the compressor. Okay, then so when the compressor on, what happens? Your pressure increase, right? Okay. Then when the current pressure more or equal to cut off, then compressor off. Okay, finish. So when compressor off, what happened? Pressure drop. So again, when pressure drop, I on again. So just continue.
No need to start again.
No need to start again. So they continue until I press stop. So when I press stop, okay. So what I want you to do, this is scaling, right? Scaling you do in a FC2, because FC1 is a compact, and so we don't disturb. So FC1 is not related. FC1 is just for learning, testing. Okay. So we need to do scaling, right? Yesterday, like yesterday, now max scale, right? Okay. Then this process, this flow, you create in the FC3. So we will have a multiple FC. Okay. So if you want to know how, actually this one, you can open two TIA portal. If you want to refer your old one, you can open also. But you cannot open from this TIA portal. You minimize this TIA portal. You open from the folder. If you want to refer the SLS project or something, right? You can open like that. Okay, can? Okay. I think if you want to take a break. because when we do this project, once we finish, then we test lah one by one. Test, okay. Then we can do the SCADA for this one. So in the SCADA, very simple lah. Just put start, stop, compressor, then current pressure, then cut in, cut off radius, like a set point lah. Here, when you do this, of course, very simple. This one need to do comparison, correct? And must use compare, right? Okay. When you use compare, for the cut in and cut off, you want to use constant number pun boleh or some memory pun boleh. It's up to you. Okay. Then in the SCADA, maybe we can do tracing. You see the graph. You can see the graph when the pressure go up and down. But that one later lah.
Kita kena ingat balik macam mana nak tengok ni. Kita punya analog data ni. Macam mana data tu? Yang kan saya punya start pada 64 sampai 67 kan. Tak pun nak tengok tu. Tengok. Tak ada yang ni bukan ni. Betul. Orang kata device configuration. Yang baru ke kontinuen yang lama? Sebab kita boleh masukkan value tu, tapi kita tak tahu kita punya analog sekarang I berapa.
The scaling and compare in one FC or different?
Scaling in one FC.
Okay.
Compare you do with this program, the start stop.
Together with this one.
Yes, yes. Yes. Okay. Go to compare to ini compare lama punya. Okay. No, I want to compare. Itu up. So MW8 tak boleh guna, 10 tak boleh guna, itu up. So any memory daripada sini jangan guna dekat pressure ni. Okay, go to pressure. Okay, so MD2 memang tak boleh guna lah. You right click rename MD2. Rewire. MD2 put MD20. MD20 sebab 2 tak boleh guna. Yang kita buat scaling ni kan, from 0 to 27, right? Okay. Yang 2764 ni saya dapat daripada mana? Where I get? From the analog, right? So analog punya address apa? Actually bukan MW4, IW64 kan? So tukar dia, bukan value tu. Double click, no need rename, dia tukar. Just double click, padam IW64. Create new. Kena create baru. Enter. Okay, the new tab. Right click, rename. Tag itu analog input. Yes. Okay. Change. Yes, baru betul because this is the value, right? This value is the IW64 kan? We convert, barulah kita dapat. So ini aku tukar, kalau guna MD, tukar kepada real. Tukar real. Sebab dia guna MD, right? Okay. Now the compressor kat mana? Now no, this one. Bukan macam ni. I want to compare, right? I compare apa? No, I know this one is okay, correct. But this one wrong, it's two. Saya nak compare. I compare apa actually? Current pressure dengan cut in. Maksudnya ni pressure, ini cut in. So ni pressure, kan kita buat apa, compare kan? Apa yang buat we scale, correct? So kan kita dah scale ni kan, yang kita ni kan IW64, right? Okay, we already convert this into a pressure. So if I want to compare, I must compare the pressure how much will be less than the pressure compare with cut in. Bukan cut in compare cut off. Pressure compare with cut in. So daripada mana saya dapat pressure? From the scale.
pressure that
Okay, what we do, we remove. Which one not using, we remove. I think you confused. So maybe the compare tu kita boleh remove lah. Tadi punya compare. Maybe sebab just now ada compare right. The previous yang just now we do right. The compare ada, maybe this compare ada. That's why maybe confused. Okay. No, no, man. We go to project. Save as. Tak perlu padam nanti. Just different version. Okay, day 4 lesson 1 compressor. Okay, save. Okay. So yang compare ni delete. Yes. Kita remove dan kita tak guna tu semua remove. Go to main. Main delete. Okay, go to show all tag. Okay. So start compressor. Okay. AI. Okay. Cut in min max. Dia tak ada cut in min. Just ada dua saja. Correct tak? Ada cut in, ada cut off. That's all. Two only ya. So yang daripada sini sampai number 10 ni. Wait. Undo. Okay. You click here first. Click sini dulu. Maybe some other place. Here. Okay. Now you click here. Click at the click then tarik. Yes. Until number 10. Delete. Yes. So stop compressor ini compressor pressure reading convert reading. Okay. Delete. Nah, daripada 4 sampai 9 delete. Because so many memory that's why you confuse. Enough. Okay. So kita ada stop compressor dengan analog input. Correct? That one you understand?
Yes.
Okay. Now you go to the pressure. Okay. So ini bukan ini padam. Delete. Okay, wait. Okay, we create here. Okay. So kita tak ada apa-apa dekat table lah. So what we are doing here, we convert the analog input into pressure, right? Okay, so you use real ataupun you change to integer lah, macam tukar kepada integer. Okay, then ini tukar kepada 0 and 250, not 0.0. Out. Okay, you click here. So I start from the MW10 lah kan. Okay. MW10. Enter. Right click, rename pressure. Okay, finish. Kenapa ada pressure nama dua? Oh, okay, this name is okay. So maybe you right click, rename you put pressure value ataupun current pressure. This name, you put this name, current pressure. Yes. Okay, finish. Okay, kita convert that. Now we do this. We go to compressor. So macam ni salah, because you cannot on output 2 times. Correct? So network 1, network 2 did. No. This network. Click delete. Okay, this start stop compressor ni betul kan? Okay. Now this one you can delete first. We do one by one, then only we can understand. Okay, delete. Okay. So now you see, start. I must compact. That is the current pressure must be less than cut in. Correct? So I click here, go to instruction. I think you delete this. Delete this also. We do one by one, then only you can understand. This stop only.
Stop it.
Stop delete. No. Click here. Delete. Go to instruction. Okay. Less than, right? Okay. Take less than.
Less than.
Yes.
Okay.
Take it for you. Okay. So saya nak compare apa?
Pressure.
Current pressure dengan cut in. Okay. Current pressure letak dekat atas current pressure. Okay. Don't search. Memang tak ada. Kita kena create. You know why yours got so many wrong? Because all the data you cari dekat tag table. You only can search dekat tag table adalah start, stop, compressor. Because these three is the input output. Selain daripada ni semua manual. So we need to create. Okay. Now cut in ni you have 2 options. Apa cut in punya value? 180, right? So you have 2 options. Number 1, you directly put 180 here. Ataupun you letak satu memory, later we key in 180. Okay, both way also can. Okay, but now I just put 180 cukup. Okay, enough. You should test this one dulu, baru boleh next step. Okay, go to main. Yes. Okay. Drag both letak sini. Go to pressure. Letak dulu. Yes. Okay. Actually by the best way is kita buat pressure dulu kan. Kita kena test pressure dulu. Baru kita boleh pergi ke next step. So just now your pressure is already wrong kan? But belum. So you must do the pressure first. Finish the pressure first. Okay? Download this. Test. Save, download. The best way, like I said, ni kena convert right? So I need to convert. Okay. Convert this. I do this first. I convert. Okay, I check dulu. Boleh dapat pressure tak? Okay, boleh dapat. Then I go here. Saya buat ni dulu. Start. Check the pressure. Compressor on. I make sure compressor running. Then apabila lebih compressor off. Need to test this first. Barulah I boleh buat repeat stop. That is the best practice. Kalau if you try to finish everything then test cannot. Sure cannot. Sometimes you cannot imagine. What I do betul. Best way is always one by one. Okay. Now go to pressure and monitor. You open pressure. No problem. Open pressure. Monitor dulu. Check dulu. Ada dapat tak pressure? You can increase and decrease. Go to maximum and minimum. Why? Okay, down dulu. Increase. Sudah. You go to 10 volt. You tengok dulu dapat tak 250. Work. Now only we continue. Okay, go to compress. Go to yang compressor. Yes. Okay, monitor. Monitor. Yes. Okay. So now the pressure is under 70 kan? So it is below under 80 lah. Nampak tak ini hijau maksudnya? Dia boleh. Okay, now you press start. Yes. No. Put below under 80. Okay. Okay. Now press start. Dia on tapi bila saya lepas dia dah off kan. So what I need to do now?
Increase the.
No. First we do this one. Don't increase first. First kita set. Start. Bila saya tekan start, saya check dulu. Okay, when I start, I check first the pressure is less than 180. I must on the compressor, right? Okay, you press on. You press, dia boleh on. Release, they off. So what I need to do? Yes. Actually, you see, that is how you need to do program. Test one by one. No worries. It take long time, no worries. Yes, open. Tak perlu. Because the moment you tambah, you add, see, dia dah automatic off. Save, download, test again. Have you tested belum?
This kat electric test. This.
No, it won't work.
Huh?
It won't work. How you test? Okay, download. Okay, you bagi dia less than 180. Okay, tekan start. Okay. So you tested until here.
And then
Okay, jadikan dia lebih. Okay, wait, what happened? Cut off kan? Is it correct? No, because you see, I start, I compare the pressure, compressor on. Apabila pressure lebih daripada 210, baru compressor off. Correct or not? It's not lebih daripada 180 dah off lah. Then how the compressor can go up to 210? Tak boleh. So cannot right? Means, so this is where the logic lah. So ini cut off kenapa? Sebab ni dah off kan? Okay, but I want the compressor still to be run. So what I do, this one I put inside the branch.
inside the branch.
Yes. Tarik, letak dalam branch. Yes. It means, okay, basic ah. There's a meaning, you know. Outside the branch, inside the branch, there's a meaning. Inside the branch means yang ini adalah satu interlock for my start button. Means if I want to press start, I make sure pressure less than 180 baru saya start. Lepas tu dia punya function dah habis. That's all dia punya function. Dia punya function adalah compare less than on back. So siapa yang off dia adalah pressure more than cut off. Okay, you save, download, you test again. Yes.
For the second sequence, means we don't have to press the start again, right?
No, it continue. When the pressure dia kurang daripada 180, on back.
I use a pulse. It's okay.
It's up to you. We see how. Okay. So now you test again. You will reduce. Yes. Reduce below 180. Okay, wait. Okay, now you press start. So you see, when I press start, I make sure the pressure is below 180. Baru saya boleh on. Can right? Can on lah. Okay. So you increase slowly. Okay. Okay, wait. So you see, here a little bit. This one cut off already, right? But my compressor is still on. Correct? That is the correct question. Earlier we don't know. Earlier kita letak dekat luar because we don't get the idea. But just now when we test, apabila dia more than 180, compressor off. But the compressor should not off. Dia kena continue run. So kita kena dia bawa sekarang. Okay, now until here then. Okay, now when the pressure more than cut off, kan? Kalau saya nak sekarang, kalau saya nak cut off, what I need to do?
Masukkan.
Cut off the line here, right? Okay. But this compare, like I said, is like a normally open, so I cannot put it here to cut off. Okay. So what I do? Go. You add one branch here. Okay. This is compare what? Greater equal. Okay. You add the greater equal, more than equal. Okay. Put integer dulu dalam. Always select that. Okay. Atas the same current pressure. Okay. Put current pressure.
From different block, function block. Yes, I cannot simply put this one. Put another one block.
And
Just
you
not
need to move this.
Just not start working. This way I need to put this one.
No, because yesterday project I do move because I want to teach move. That's all. If no, I can directly use that. This one can go for. Try it. Okay. So now yes. So when the pressure is more than this one, I create an output. You create an output. Okay. Create a memory. Create new memory. Memory apa yang kita belum guna? 0.0 kita belum guna yet. Okay, try 0.0. M0.0. Okay. Enter. Right click, rename. Letak nama cut off. Okay. Change. So you see, when I start, I check the pressure. If less than 180, okay, on the compressor. So I latch it. So ini dah lebih 180, I don't care. Sebab yang ini adalah this interlock is only for start. Okay. So when the compressor is on, okay, when the pressure is more than 210, cut off. I use these to cut off here. Letak sini. Normally close, cut off. This is the first sequence. Okay. So for this one, this pressure, right, I can leave it like this, or I want to put interlock also can. Yes, the compressor can. Yes, that's how it works. Without also can, with also can. Better is the with. Better, yes. But there's not much different lah. But you put, so better for understanding also. Compressor. That's okay. Can you repeat? Can you repeat? There's no okay.
So why you cannot insert the pressure area?
This one.
Yeah.
Here. Try and see.
I will try you.
Huh?
You try the one.
You try this one first. Then you try this one here first. Can also, no problem.
This one I have 222, right? And then have this one. And then SMS.
Will clash, right? Is it using this one?
Yes.
Not using, maybe it's wrong one. This one is using, right? Right in middle. Use this one, is it? This one, right? Internal. So you put it here, right?
Yeah.
As you see, because here you straight away use the number address really, right?
Yeah.
Okay, so okay, this one because where are you using that? No, right? Where are you using this? No, there's no one. That's no need. So because okay, yes, right, I mean you do inside here, right? But I put it here. The same amplitude. So here also write. Someone is writing value here. Here how much the value? 0. Understand? So the problem here is one is you need this. Because you already used here. Unless you put input, then here put input. You put output, then this output you use here. Then here you can put the analog and now you should put this. So you can not using that anymore. Okay.
No, no.
So if this one here, this one I can use here as well. Instead of using these, I can use this. So you need to understand. M means global. This is internal. If I am not using, you need confusing. Now you download. Okay? Okay. You try. Now you try to put this to here and see whatever. Can work or not.
Can I copy this level 1 to level 2 for test?
Who cannot?
Yeah.
Cannot. Because it will clash. Because you are using same address.
Same address.
It will clash. But now what? Just take this one, put it here. Copy and paste.
Cut.
Right? Cut, copy. Copy and paste. Then the cut off to take out. So cut off to take out. So delete. So means this program won't affect this. So now this one different, this one different really, because you are not using this.
Yes.
Now you test and see. Now you know number the volume. Okay, bro? Okay. Try to do the on that. I give you idea. Okay, on that. So I need to press that again. Now I press the start and hold. Now we increase.
I know why.
You see,
The different value on the
different, right?
different.
So
Yes.
because this one is like a normally open within interlock, so I directly can use. But this one I can't directly put here because I want to cut off. So I create macam ni, memory I put it here. Please. See, I need this. So this area must be always on. So they really need. Okay? But my start button not always on, right? How? What I can do so that when I press here always on. The idea is this place, I don't care what is here, start or stop or whatever, but this place is something here is always on and then repeat. That is the idea. So how to do that? Try and see. Get any idea? Now okay.
The program is okay. But just now the
Meaning, okay, I will show you. So you do this element. This one got what? It's a subroutine. If I'm using this one, it's called the code block. You want to do code block? Can. So this one I leave it SCL code. Here you put AI. Here you put scale value. Temporary you put counts. So now I'm using code block, right? So if I'm using code block, here I need to put the AI. No. Where is my AI? This one will
real.
now my slide. So I need to put this. I must use this. Okay? 0 0 I'm not going to use anything, I must use this one. Okay? Now, see, I'll add it right here. Easy to see. Okay? Okay, add. This one put inside here or here also same thing. Now, you put the AI. AI is right. Here you get W30. Okay. So you see, earlier because earlier you put something here, right? So all proper effect but you didn't use the internal tag. You used already straight away use the addresses. But inside here, I use only the internal tags. This is what the code block means. So now this one can go. You try doing this.
This one can go.
Yeah. Now down. Okay. No. Wait. First, the command name. Okay. If let's say, if I want to know that one is working or not. So I check the IWC Increase. Okay. Right. So the output goes where? MW12. Right. So if you want to compare, must compare MW12. So because pressure is only one. Here is a wrong because for two pressure data. Pressure is only one. So ini integer. Because why integer? The pressure is what? Integer. So kalau nak compare integer. So here also MW12, here also MW12. Baru. Okay, got it?
Amek tak tahu.
Basically, when you do changes, so you will reset the call and when close it. Okay, see? Now go to the level. Okay? Here I straight away address in the non-SKS. Here I use the internal tags. I do this using the internal variables lah. Then later on when I call, dia akan jadi macam ni. Then two type of
Means tadi yang aku ada dalam function block, I pakai
okay.
yang betul-betul. I don't know.
Yes.
I bukan pakai
The internal tag. Okay. What you did just now. Okay. Let me show you here. Again, what the mistake you do? You create this one. In and out. But here you straight use the actual address. So this one. You use 30, right?
Yeah.
So you do this. So here also same. That's why the MW30 doubling now. Here cannot give the value, but inside can show the value. Because wrong. Okay.
In main,
I'll show you. Okay. See no value. And because you know why. But here this one can get value. You know why? Yang outside yang IW64 tu value tu bukan masuk sini. Masuk sini. But we're not using here.
oh,
And
but how this one is connected? Is it got the address? I mean, this one I put myself, right?
yeah.
Then I thought put address, just a name on that, and also the data type.
Mhm.
And then from outside,
From the outside, you when you link to the AI, the value will go to the AI.
without putting any address, and link to AI.
You mean this? This address. I need to put this address, but okay, now this value is not going to the non-SKS actually. It's going to the AI.
Oh, this one.
And this zero I get from where? I get from the scale value. When I open and see, I never use anywhere. That's the problem.
I didn't even read this.
Just now I changed it.
I don't even read this one.
Oh.
Because this one, I'm the one who made it, right?
Yes, correct.
The program
Keyboard.
go to compressor.
now you stop. Stop. Okay, now you decrease the value. Yeah, start again. Clear.
Oh yeah.
It's using pulse, right? Because the pulse don't have any interrupt in front. So, if any time, even the machine compressor not working, if the pressure from go below 180, then automatically off. Even though you're not starting. So how?
So it means
Can use the pulse.
cannot pause. Means my problem is even though I stop, the compressor goes down, still running.
Yes, that's the problem.
Okay.
Just can you? What any idea? Okay, now okay? Okay. Now this one working, huh? Working, right? Okay. But this one is just like one cycle, right? Kena start looking betul lah. So how am I going to repeat? Bila dia kena on balik, when the pressure go below 180, must on back. Okay, go below 180. Okay, so means when I go below 180, this one is ready. But saya kena start balik. Kan? Okay, now what you try? You press the start button, press and hold. Press and hold. Okay, now you play with the pressure. Now you increase the pressure. Okay, can cut off, right? Okay, now you decrease the pressure. See, can on back. Tapi if the start button is always on, kan? Okay, release. But we cannot always press that start button and hold, correct? Because our start button is a push button. So what I can do so that this area can be always on.
This one,
What I can do? Can I erase this? Kalau normally close, belum tekan start dia dah boleh on. Means this area when I press start, baru dia sentiasa on. Kalau saya belum start lagi, dia tak boleh on. So we know this area, right? So it can be anything. Okay, not necessarily start button. Okay, so we get. So we see first. Now we know this is less than okay. Then whatever lah here. We know this one must be always on. But if I put the start, cannot because it's a push button. Okay. My question is how to create something that is always on when I press start. Actually I can on a memory, right? You see, I can click start and I create a memory. What memory can use? In your case, M0.1 can use lah. Like others, you see lah which memory is available. I just put here run memory this one M0.1. So saya tekan ni, dia on. I leave, dia on. If I latch it, I press, dia sentiasa on. I can use this here. Right. So when I press the start, this memory on. This memory now can be here, can be always. So I can repeat. Because that is the idea, right? Because just now when you press the start button, I mean this area always on, it can repeat. So, but my start button is push button. So from the start button, I create a memory that can be always on until I press stop. Very simple. You create satu memory di bawah. Go to network 2 and create. Need to change this to run. Kan? Can right? Yeah. Okay. See, if you do one by one, can. If before testing, if you do all, yeah.
I really selalu confused dengan exercise.
Yeah. So you can practice lah. You need to practice. But this one is a logic lah, no problem. One by one, we test it out, okay. But most important, the address. That's why yours saya suruh padam yang lama because you confused already, I know. Because the way you guna tu saya dah tahu, okay, ini confused, okay, never mind. We delete everything, we do new one, so better.
Sebab saya macam programming lah untuk file punya sistem ni boleh sikit lagi sikit kalau saya kata boleh sambung.
Yeah, of course.
Logik dia boleh sambung jadi hasil.
Yes. Like satu apa? Because logic no problem. Because logic is different people, different style of logic, kan? Okay, ini program pun there's another way to do it. There's, I think easily in this simple program, easily 3 to 4 type of programming you can do for this simple one. So bigger one, you see how many type of programming you can do. So the thing is, but the most important addressing is important. When you do scaling, okay, what type of addressing? So macam tadi, input tak dapat. Why? Because input must use IW6. Like yours, you already do the scaling NW12, but when you use in your compact, you calculate and you create new one. So no need to create new one. You already have the memory, so use that memory. So actually, when you do this one, naming is very important. The number is very important. Start, stop, compressor, but it's now current pressure and so when you put a correct naming, it's easy to do properly. Okay, good. Okay. Go for your break. Then after the break, you come back and we do SCADA. So for that, remember, macam HMI we use start stop, not we use memory, right? Okay. So we can use DB also. So later we will learn the DB, global DB, which is another interesting topic. No, it won't be confusing. You just need to understand. Otherwise, similar to memory, tapi dia block type. So later once you use that, you will feel DB lagi better daripada memory. Later lah, once you finish everything, then you will feel better.
Biasa kalau dia buat programming dia pakai macam ni, pakai logik apa tu?
Memory or DB. Okay. If you ask me, if let's say this one, It's just for PLC only, no HMI. So I just normally use memory. Senang. Okay. Kalau if I want to do HMI, then this one I use memory. You go up. This one I use memory because this one I'm not going to show in the HMI. This one I will use memory. But this one, current pressure I will use DB because I want to show in the HMI. So that's what later we will do. So you can understand better. So when to use DB, when to use memory. Okay.
Saya besok agak-agak buat kita lagi.
What time you want me to finish? Normally before 4 lah. Before 4 all we finish lah. But later once done, we can connect we do the SCADA. Once we do the SCADA, we connect the blue color motor to this PLC. So that was the same thing, the same analog. Just need to do normal simple on off. Once done, then tomorrow morning we do the Cinematics. Cinematics also is a similar thing. Okay, just the value are different. Then we do a simple project. Then tomorrow you have Friday prayers, right?
Ya, so tomorrow saya lewat sikit lah. Okay, saya
Can. Yes, sure. Near the bus. On the way,
Belakang ni mana masa? Belakang.
that one ada dekat Sutera Mall sana.
Oh,
Near to, tapi it's not walking distance lah, kena bawa kereta. But here is very near.
oh, yes.
No, still need to come.
Oh,
Very near. Masjid Kampung.
masih dapur ya.
Yes. If you drive, then you can go very near.
Okay. Stop to lunch.
Yes.
Bring my other one laptop.
Mm.
Can
program, right?
Yeah, I will install the simulation as well. Yeah.
If you get fined here, where do you pay?
Can pay online.
Online.
Through the MEJP app. now we do SCADA. Okay. So this is our project. So what we want to show in the SCADA. Start button. Stop button. The compressor. Okay. Then the current pressure. Okay. Then the cut in, cut off. All value lah. Now the cut in, cut off is a constant number, right? Okay. For compressor, we can use the Q0.0, but this one is MW12, right? Okay, you can use the MW12. This one need to add that. But what I want to do, I want to add a DB. Okay. So what we go to add new block, data block. So global lah. You name it SCADA. Okay. So this is the DB, yeah? Okay. You right click the DB, go to properties. Okay. You click on the attribute and this one the optimize ni. Uncheck. Yes. Okay. Alright. So this one, okay, if I didn't optimize, okay, you won't get the DB address. Okay. If I uncheck the optimize, then I get the DB address. Okay, DB1, right? Okay, DB1. Then kalau boolean DBX 0.0. For boolean sama macam M0.0. Okay. If it is a word, DBW0. This is a integer lah, 16-bit. If it is a double integer, DBD0. If it is a double integer or real, similar like M0.0, MW0, MD0. Same like memory. Okay. But what is the advantage of DB? And because you can create 1 DB, inside here you can list down all the data you want to share in the SCADA. So you don't need to worry about which memory you want to use. Which memory you want to use. That is number one. Number two is DB can keep value. Remember yesterday for the function block, right? He erased the timer value, but the timer is still there, right? But memory not like that. Memory, when the PLC go to stop and run, memory becomes 0. Okay? Okay? Okay, now list down what we want to show in the HMI. We want to use the start. So normally what we do, we use memory, right? Start, stop, end. Okay. So for now I want to use DB. So key start, stop. Okay, start, stop is a boolean, right? Okay. Now current pressure. Current pressure already ada MW, right? But I don't want to use the MW. I want to use the DB. Yeah? So you click current pressure. Current pressure is actually what data type? According to your integer, right? Choose integer. Okay. Then cut in, cut off. Okay. Save. Now what we do? Go to your program. Okay, is it pressure, right? Okay, where is your start? For start, we branch. Remember when we create the HMI start kan? Same level. You create a branch untuk start. For start, you add a branch. Okay, normally what we use some memory, right? We already created the DB, so you can use the DB. You key here, go down, look for this DB, SCADA, yes. Click there, start. Okay. Nampak ada DB1 kan? Okay, never mind. Question mark never mind. Click here, connect up. Okay. So kalau ada question mark, you right click the DB, compile, software only changes. Okay, bring it up. Can you see? Dapat ni X0.0, right? Okay, for stop, you add normally close. SCADA stop. You can type also SCADA. Then you key a dot. Okay, they go. SCADA stop. Okay. So lagi tempat mana stop? Go up. Here also right. Here you add. Okay. Now, this one is the cut in. Okay, under 50 tukar kepada cut in. SCADA cut in. Yes. Go down. Ni, SCADA cut off. Okay. So let's do current pressure. Go to, actually saya boleh guna ni kan, saya boleh remove dia. I can put the SCADA pressure and okay, but I don't want to do this, don't want to disturb our original program. Okay, go to scaling. Okay, from the scaling is, this is the memory, right? This memory I use in my program for the comparison. Okay, so if I want to show this one in the HMI, I can use MW pun boleh. Okay, but I don't want to use MW, I want to use the DB. So you add a move function. Okay, so move apa? Your MW12, you follow your MW up. Then I move to SCADA current pressure. Yes. Save first. So now all these are using DB except the compressor lah. Compressor tak perlu sebab it's the output. Except compressor, all these like yesterday all what we did. All these we use MW, right? Using MW like yesterday for timer MD and for start stop we use the M0.0, 0.1. Okay, so I can use memory or I can use DB also. Okay, what is the advantage? And so the advantage is very simple. You can, whatever you want to show in the SCADA, you can list down in 1 DB. Easy to troubleshoot. Okay, okay. Double click here.
Sorry sir.
Yes.
My scale is
Okay, damai. I'll show you. So you see 0.0, 0.1 right boolean. Next one is 0.1, 0. In boolean lah kan. Okay. Maksudnya dia sudah guna byte 0 betul tak? Next available is byte 1, right? But you see when you put here, automatically using the byte number 2. Walaupun byte 1 is available, but the software itself using byte number. So normally when the software itself, it won't use the odd number, always go to the even number. Even though the 1 is available, 1 point, still 0.2 sampai 1.7 masih lagi available. So if I want to add any boolean, I can add. Or I want to add below here also can, no problem. Because all this in B. So like I said, memory, right? Berapa byte ada? 4,000 bytes. In 1 dB, can go up to 32,000 bytes dalam 1 dB. And the dB number can go up to 65,000. Because some dB dia guna untuk timer counter, right? This is global dB. So the dB number can go up to 65,000. Maybe if, with the name, maybe you can put the name lah, pressure scaling. Right click, rename, pressure scaling. Move function. Then save download. Monitor. Okay, you see the value move here. And okay, you go to your program, the compressor, monitor. Okay. You stop. Stop. You right click the start. No, start. No, SCADA start. Right click the SCADA start. See.
Oh, SCADA start.
Yes. Right click, modify to 1. You see, you can modify. Right? Similar to memory. Okay, you modify to 0. same like memory, I can modify. Now, so if this one done, the program is done, same like HMI lah. Go offline first. Okay, offline, then can go to add new device. So yesterday day before all we add HMI, right? So today we can add PC system. Yes. So if you're using the Siemens PC, you can use the industrial Siemens PC, everything lah. But now we are using our own laptop, right? So you can use the PC general, PC station. Yes. Click OK. Version memang cannot change. Now is our laptop. Okay, so we are using Ethernet cable. So I must add the Ethernet punya adapter lah. So if I'm using the Siemens one or the special cable, I must use this. But now I'm using a normal Ethernet cable, so I choose the IP general. Yes, double click. So it's added here. Okay. Then go to SIMATIC HMI application. And choose the runtime advanced. Can use runtime advanced or professional. Professional ada banyak function. But professional normally they will hang the laptop. So we can use the advanced. Double click. So we can use professional or advanced also. Professional have more functions also. Okay. But professional will hang the laptop. So we use the advanced. It's the same thing, only a little like additional pipes or that. Okay, once done, we go click here. You connect the PLC and the HMI. Drag, connect. Yes. Okay, yeah. That's all, finish. Now go down. Here, go down. Same like the HMI. Can you see? I have a HMI runtime. We call WinCC runtime. Open. Go to screens. add new screen. So manually add, because HMI when you open, right, you bring step by step. Right, this one don't have, so you need to manually add this. This is the screen, you click on the, before that, go to runtime setting. Okay. Runtime setting, double click. Okay, you uncheck the full screen. No need full screen. Okay. Go back to the screen. Double click. Okay, so you have more functions. Go to element. Here also element is show more functions. Okay. So that normal you can just do start stop and okay. Okay, you take a button, go to element. Take the button. Okay, just put it here. That normal. Okay. Okay, right click properties. So bring it up. Okay. So normally for what if like this you click here, property page. So normally for button what we do, we change the text, right? Okay, change the text. Then we go to the event. The same thing. Okay, click on the press, add function, choose set bit, okay. Okay, no, wait. Set bit. Okay, what is here? What we need to choose? Start, right? Okay, you click here. So normally from where we choose the PLC tag, right? Okay. But for now, only compressor is at PLC tag. The start, stop, all this is inside the DB. Correct. So we must go to program block, choose DB, choose the start. SCADA start. Wait. Okay. So go to release, reset it. Okay, done. Now you do for stop button. Event. for the compressor, right, normally you use the shape, right? Okay. For SCADA, actually you can get the compressor pictures. Okay, where is it? Is this one. Drag and put it here. Okay, but if you want to change color, same animation, we need to use animation lah. But before that, go to property, appearance, the style must use shaded. Click here. Because you see, original cannot change color. Shaded can change color, foreground color, right? Okay. So must activate this. Then you go to the animation, appearance, appearance. Yes. Okay. Then as usual, choose the compressor. Okay. Now the compressor where is in PLC tab. Choose from the PLC tab. Okay, zero one. Here, next one. No, this one is zero. You tambah lagi satu. Add name. Okay. Now want to change color, right? What color do you change? Background or foreground color?
Foreground.
Yes, because foreground is the black color. Okay, so change the foreground color. So when zero, what color? One, what color? What to do? Okay, good. Yes. Then the rest is same lah. This one, right? All these are IO field, right? It's the same thing like yesterday we did in the HMI. Okay, and here the IO field for the current pressure, cut in, cut off. Yes, you just put it here. Yeah. No, not under tag table. DB. Under program block. Yes. Current pressure.
No, input output.
No. Current pressure output. Cut in, cut off, input. done. Okay, save. Okay, now right, click here the HMI. Choose the HMI here. The runtime here. No, just click on it. So then click, go to online. This one, RT is runtime, sorry. The WinCC RT means runtime lah. WinCC runtime and one. Okay, go to online. Cannot download lah. Online. Start runtime. Yes. Because this is a SCADA, cannot download. Only HMI can download. Cut in, you just key in like 150, sorry, 180 to 210, right? You key in the values. Must key in. This one, it won't pop up the keypad. Because the HMI is pop up the keypad. 210, 250 too big. Enter. Okay. Let's start. Of course cannot, because the current pressure is more than your cutting, right? Decrease the pressure. Now your compressor running, now increase the pressure. 210, go 210, we cut off. Decrease again. Okay, good. What step? But the current pressure, can you show current pressure? No, I can't key in the value. Never mind. Minimize it. Go to your neutral. Can you click here first? Properties. This is the current pressure is the output only. Okay, and this one can be in out lah. This one in out. Okay. Now go up. You save this project first. Okay. You click the runtime. HMI. Okay. Go to online. Start runtime again. Kan? So dia akan tutup, buka balik. Wait. I want you to make it smaller. This sampai sini. Ini pun sama. Okay. Then this one bring it to the right side. Okay. Now you go up in your program. Go up. Go to your program. Where is your program? Yeah. No, this one. This one is the program, right? Okay. Go online. go offline. Means cannot communicate. So if you have a hashtag means cannot.
This is also you.
Hashtag, okay, then I will show you one. So if you show hashtag, it means there's no communication between your laptop to your PLC. Okay, but the program can communicate, correct? You know what is the program? You go up, right click your CPU, the PLC, properties, go to connection mechanism. Yeah. Okay, this is the one. Okay. So here uncheck, right? Okay. Here okay. What do you do? Okay. What do? You right click, download the hardware configuration. Means inside the hardware is ticked. I mean the earlier project or
Only show software.
only showing software. Do you right click it?
Yes.
Then you go offline. You're still online, right? So when offline only can show hardware configuration. Oh, it's an earlier one. Okay, now okay, you see the runtime? Now, because that one normal lah. Because you see version 4.6 lah, sometimes dia automatically dia guna secure communication. So every time we need to uncheck, then hardware, download the hardware. Okay. Enter. 210 2 bit, 180 lah. Enter. Okay, now you reduce below. Okay, that is SCADA, that is DB. Okay, if I'm not using the DB, also still can do. Okay, so if I'm not, for this one, just for example, if I'm not using the DB, still can use. Let's say this one M20.0, M20.1. This one you already have, right? Maybe MW10, MW22, MW24. This number are example. Okay, so even you can use memory also. If you don't want to use the DB for this, but what is the advantage? Memory means, okay, you know, it's not like sequence, right? If you want to troubleshoot also, it's difficult, right? So DB means, okay, you create one DB, whatever you want to put in the HMI, everything you do in this DB. So, yes. Now, go to your screen. Now, what I want to do, I want to create another screen. Okay. So you go down here, and in the other screen I want to do the trending. Go down, add new screen. Okay. You can bring in the first one is main screen. The second one is the trending screen or trend screen. Now go to main screen. Okay, you take one button, put it here. You put the name trend. Okay. Now right click this property, put event. Click press. Normally what we do, set bit, reset bit, right? That is for if you want to on some DB or some memory, like some button lah. But this button is to do change screen. You click here, you go down, go for screens, okay. Activate screen. Ataupun you can type here activate screen. Then what is the screen name?
Trend.
Yeah. The same thing you do at the trend screen. You open the trend screen. Yes. Open. You add one button first. This one name you put main. Because you want to go to the main screen. Activate screen. Yes. So what is the screen name? Main screen. Okay, save. So this one is to change the screens. Done? Okay. blank. Sorry, you click first. Click the button first. Okay. Here. No, click the button. Okay. Whenever you do property, make sure you bring for button. That one must be correct. Add functions. Okay. Activate screen. Main screen. Yes. Okay. Good. That's all. Go to the main screen. Ini sudah right? Okay. Yes. Okay. Now go back to the 10 track screen.
Nice.
Okay. This one can close first. Okay. This one can bring it down or up. Okay. Not so. Yeah. Because we want to make it smaller. Okay, now we want to do the trending graph. Okay, go to control. Take this one, the trend view. Yes. Okay. Trend view. Okay. Right click, properties. Go to property. Okay. Ada banyak property. Okay. So we want to know the first one like trend. Okay. Double click here. Just put the name pressure. Then the source setting, from where I want to get the pressure value, from the dB, right? Yes. So the process value, choose the SCADA dB current pressure. Okay. Okay. Alright. So style, maybe you can change the color. So you can see, you can easily see. Okay?
No, I lost.
Okay, never mind. Oh, okay. You go back to the trend screen. Okay. You don't do any changes here. That's why whenever you doing, make sure what setting you are doing, that is important. Because if you do wrong setting, there will be error. Okay. This one can close first. Ini main ni tarik bawah sikit. Okay. Take the trend, add here. Yes. Okay. Now right click properties. Okay. First trend, okay, here double click. Add pressure. No, pressure. Then the source setting, choose your SCADA pressure. SCADA current pressure. Yes. Okay. Then maybe the color, you can change the color. What color? Maybe some bright colors, green or yellow or red. Okay.
The mode is okay.
Mode okay, itu boleh. Let me show the result. Okay, just enter. Or just down. Cannot. Never mind. This okay. I think it's already done. Now when you click it, it's already clicked. Okay. Next, you click on the appearance. So now some settings lah. Okay, go down. Okay, the time exists because this is the time. Okay, here is the value, how much. Okay, so time is 100 seconds. Means the point you have 100 seconds. Total 100 seconds. So your just now the trending also is 1 second. Every 1 second, if you read the value, update in the graph. Okay. Then left axis, okay, put 0 to how much our scaling just now? 250, right? Okay, put 250. Okay, right? Okay, it become 250, yeah? Okay, right, so 250. Okay. That's all. The rest is additional settings. These are the main settings. The trending and the axis. Okay, finish. Save. Okay. So same like just now, you click here. Good. Actually, you can right click also can. Online, start online. Okay, go to trend. Okay. This one bring it to the, can you see the graph? This one, yes. This one is to show the value here, the below. Okay, now to increase, decrease, you can see here. This is green color too, right? You can use some other colors. So you can see here the value, and this one you can move. So you want to know at 28, at 228 what is the value? At 230 what is the value? You can see. Of course lah, dia belum lagi count, so of course dia hashtag like no value yet.
Let's start online to open the main screen. Just to go.
That's the trend.
Why the value sometimes have, sometimes don't have? The value. I don't have the hashtag like that. I have value.
7.
Yeah. 7,
Okay.
22, 28.
No, this one. He said this value is based on the line here. You can move this line actually.
Oh, the middle one?
Yes, yes.
Ah.
multiple trending also can add. But you must have the multiple values. Like for now we have only one value, right? Pressure. If you have let's say two pressure values or one pressure, one temperature value, you can add also. So it will show two graphs.
Run at the same time.
Yes. You click here, but we don't have, but I show you. Right click properties. You see add new here. So I add to show another graphs. For now we don't have any other values, right? Alright, save. Any question? Okay, no question, then we can add inverter. Okay, add inverter. Whatever you've done, save first. Save. So we connect the inverter, then later on we can do new project or what. Okay. First. HMI. No, HMI. Sit here, right? Right. Same model lah, same model. Just this analog output only you need to have. Analog output. based on, well, I think yours is the same. You can choose 4.67. Yes. Yours are, you can no need to choose the middle one, lah. Just add another one. What? That is the box option box. No.
This also can turn off. Can we?
You want to turn off, can turn off. Okay, now I do wiring. Now I show you the wiring. Okay, so this one and this one. So this one can take video. Ah, so can take video. Just can record. I will stand here. This one you can see got S1, S2. Right, S1, S2. S1, S2 is for forward and reverse rotation. Okay, then can you see this is a form AI and AO. Okay. The white color cable is the AI lah. AI AO. The blue color is the common for both AI AO. So what I did is the blue cable I just bring here, connect here, and I loop to the number 3. So first and number 3 is the common. Okay, and this one, so means this 2 is analog output. This 2 lah, 0 volt positive lah, I mean negative positive. This one is the analog input, negative positive. Analog input is for this. Means from here is the output. And from here is the output, go input here. If this is the output, go input here. Okay? Then what I did is I connect a relay for the S1 and S2. Why? Because S1 and S2 must give 0 volt. Okay? But our output is what? 24 volt, right?
Yes.
So directly cannot connect unless it's a relay type. That PLC is a relay, can. So that's why I put external relay. So my output will energize the relay to give 0 volt to the S1, S2. So it can turn on. So very simple. What you need to do is you take a 0 volt. Can you put, let's say I put 0 volt negative here. Right. So take one 0 volt, connect here. Then take one 2 output lah from here. Maybe the output number 0.5. The 1, 0 and 3 don't need to touch. 0.5 you take, you connect to the relay. So you activate the relay. Then connect AO. From here AO, here is the AI. The first AI already used. Use the second AI. Then you take one AO, connect to the NO. Okay, I will do the way. I will show you the way. Okay. First, one by one, we do the wiring. look. Okay, and then positive go to number 1. And short cable to keep analog output done, right? Analog input here. So you take the 0M, go to the third terminal, the negative, and the 0 go to the positive. 0M and 0.
Omron to 0M.
Yeah, this one. This Omron. The 0 go to yeah. So this wiring diagram for this one is for small book and big book. So S1 is to is the controller for what to put AI. Yes. Okay, done. Okay. Now what you do? You take out the number 4 and number 5. Number 4, number 5 connect to here, right? 4 and 5, huh? These two, right?
Yeah.
These two you remove, you connect to the relay 1, relay 2. Yes. For this wiring diagram, I will write out. Now what you do? Take 0 volt, 0 volt from here. You connect to here. These three, right? Anyone, lah. Then you connect back to this relay com, because relay com is using 0 volt. You take 10 volt, connect any one of these three. I mean maybe first one, then second one, ambil connect. So the three already looped.
Yang S1 dan S2 memang kena dengan kom. S1 S2 bukan kalau dia kita sentuhkan ni terus dia
No, S1 and S2 is different. Yeah, right. No, what I mean is because inside here the com is 0 volt. Okay, but now 0 volt, go to the switch, then go S1. So now I'm using the relay to supply the 0 volt. The S1, S2 continue to connect. This is the output. So they actually got many, but this one is not for exactly for this. This one for the series. But near the AI1, AI2. But here only AI2 only. Different inverter, different style.
Manual auto means the inverter is inside the panel.
Okay.
So it's the conveyor line.
Okay.
The panel is at the end of the line.
Okay.
I want to start motor from here. So I just push this button.
Okay.
The motor start using inverter.
Okay.
And the way I start the inverter by using this S1 and S2.
Yeah.
Yeah, but not it didn't connect with com. Last time I remember, I think S1 touch with S2, just relay touching like that.
Oh.
Yeah, I turn on the relay.
The relay will
S1 and S2 will touch, and then the inverter will run.
Maybe it's because it's like the supply is from the means the com is from the S1. Just look yes,
Yeah, I think so.
yes. This one is different com.
It's different.
Yeah, different. Okay. So okay. I will show the wiring diagram here for better understanding. Because I treat that one because for all PLC can use. Okay. You see PFD ni ada AI2, AO and COM. Okay. So what I did is I take the 4 terminal blocks. The AI connect here. Okay. Then the AO connect here. The COM I connect here. Then I jump and connect here. So this one AI and COM, AO and COM. Okay. So this is the PLC side. This is AI means here AO positive negative. AI positive negative. So positive go to the AI, negative go to the COM. Positive go to the AO, negative go to the COM. Right?
Much more clear.
Right. So better understanding, right? Okay. Now this is for the analog. Okay. This is the terminal blocks. Now for the S1, S2. For S1, S2, I must give 0 volt. Okay. My PLC, the output, right? We use the output number what? Output number 4 and 5, right? And 4 and 5 are the last outputs. I cannot directly connect here because my output is a 24 VDC. Here I must give 0 volt. So what I did is I use a relay. So relay kan ada coil and contact. So I make it with some space. So this one go to the first relay. So the second relay. Okay. This one is the relay one. This one is the relay two. Okay. So must connect to zero volt, right? What I did is these two I loop and I come and this ada 3 terminal block I looped here. And yang dekat ni 3 terminal block I loop, right? So I come and connect here. Means so here I need to give 0 volt. Right, that's why I asked you to connect the 0 volt. Okay. So I take 10 volt, just put PS So the 0 volt I take and connect here. Okay, so if the relay is activated, the 0 volt will go to the S1 or S2, the motor can run. Now relay to ada coil, and so what I did is okay. Now I have 2 relay. Okay, 2 relay. Relay 1, relay 2. Okay, then this one I go to 1 terminal block. This one 1 terminal block. Kan ada 3 terminal block after the relay.
Yeah.
Right? Okay. And this one I loop. So look here. So this is the R1, R2 COM and for the relays. Correct. Okay, so because relay have positive, negative, positive, negative. Okay, so the COM I look and connect to the COM terminal blocks lah. So what I did is daripada power supply the 0 volt I connect here, right? Then I take 1 terminal lah, then another terminal I go and connect here. So means I supply 0 volt for the relay. So the relay need 24 volt. This 24 volt take from the PLC out. Number 4, number 5. Okay, so how it goes? This one is direct, right? This is very straightforward. Okay, only for this. Okay, so at relay contact, I give 0 volt standby here and normally open. Okay, so when my PLC output number 4 is give positive here, this one the negative I take from the power supply. same like that blank. Okay, so when number 4, output is on, this relay will energize. So this relay will give the 0 volt to the S1. Then can run forward. But before that, you must give the analog output value. You must set the speed. How much speed you want to. Okay? Clear? So now what I did is clear the cables now. Which if not, I'm not using. Check. Check. First thing. Right. Then you can check here. So the COM, right? Okay, you touch on the COM. Okay. You touch this COM, the 2M. Alright? Yes. Then this COM, the 0M. Alright? Yes. Because from here we connect it here. Now the first one is what? AI or AO?
Yeah.
Okay. Touch there. AI means here AO. So touch the 0. Right. Okay? Then here, next the AO. Okay. Touch the number 1. Because 0 is the meter. Now. So now what we need to check is the COM. Okay. Touch the COM, touch 0 volt. Because the COM must be 0 volt, right?
Yes.
Okay. Okay. Then another 0 volt is going to the the contacts, right? Okay. This and this is the contact, open contact. Okay. You touch the 0 volt, you touch the contact. This is the open contact. This is the one later will go here. If the relay is activated. Okay. Same 0 volt must go here. Alright? Okay. Now number 4, you touch the relay one. Number 4, yes. Number 5, you touch the relay one. Yes. Okay? All the connection. Now, what we did? What we do is, okay, this laptop, this PLC, this HMI already connected to here. Okay, and I just this one from here, I just do connect here. Okay, now I'm using this one. Just extend because I need how many? 1, 2, 3, 4, 5, 6. I need not 6. 1, 2. Yeah, I need 6 pot. Okay, I need 6 pot. So here only 4 pot. So this PLC, HMI, and this laptop I connect here. From here I jump. Then this laptop I connect here. Take up your internet. This one connect here. Give me your internet. Oh, ada. This one. Line 1, line 4 already ada. Line 2, line 3. Okay, alright. So all then. All dah. 1, 2, 3, 4. Okay. So now all these laptops can connect to this PLC. This HMI. Okay. So okay, now let's give me the. Now that is for the wiring. To set up the drive, because the drive can be controlled on and off using this, on and off using the S1, S2, or using the communication. Can you see RS485 here? Right. Using communication, so can on and off. Means can control this one. So now we are using wiring to control. Means the terminals. Okay. So click on the program. F0 enter. Yes. F00. This is the parameters. So F00 is the speed control mode. Enter. Yeah. Choose 0. 0 means, you can see here. 0 is the sensorless vector control. I am not important. Okay. Enter. Now F01, right? F01 is the run source. Who want to run the drive? If I choose 0, if the value 0 means keypad, means I on that. If the value 1 means terminal, means S1, S2. If the value 2 means is communication. You enter value 1. It means now the S1 and S2 can control the on off. Okay, enter. F2 is nothing, invalid. And just enter. Invalid means number 2 lah. You're not using. Okay, enter. Not important. Okay. So just now the run command, right? Now the frequency. Now who set the frequency? Okay. I can use this one to set the frequency. I can use the analog input to set the frequency. I can use the communication. So here our analog input is the AI2, right?
Yes.
Means the value must be 2. You enter 2. Means I'm using analog to control the speed. If let's say the speed is fixed inside here, so I can use keypad. Yeah, keypad lah. I may use that. Or if I'm using communication, it's communication. Okay. Okay. Next, enter. Next, number 4. Number 4. Okay, maximum frequency. Enter. How much? 50 Hz. Based on this one lah. 50 Hz. Enter. Number 5 is upper frequency limit. Enter. How much? 50 Hz also. Okay, enter. Then F6 is a lower frequency. Enter. 0. So means the range is 0 to 50 Hz. Okay, enter. Then number 7, keypad. Okay, enter. It's 20, right? Okay. Keypad means if the F3, now I'm using the analog input, right? If the F3 I use keypad, the drive will follow 20 Hz. But now I'm using analog, means the drive will follow my analog value, the speed value. Okay, so this one is the frequency, they call the keypad reference frequency. Okay, enter. Then number 8 and number 9 is the acceleration, ramp up, ramp down time. Enter. See how much I put? 2, can do 2 seconds. Enter, enter. Enter. F9 also is a deceleration. Enter. Yes, it's a 2 seconds. Enter. Now, the most important is the speed command. Who on and off. Number 2 is the frequency. Who set the speed. Number 3 is the upper limit, lower limit, then the acceleration, deceleration. Okay. Then that is to set up. Then others all you can use the factory settings like. Okay. And starting from 2.01 until 2.05 lah. That one is the motor settings, which is you must follow this. It's already set up already. That one normal lah. So this is what normally if you will do setting in the the filter, the normal settings. Okay, common setting, because just we want to do just normal one, constant load. Okay, normal running. Unless you do some special running, then you have how many? 80 to 100 parameters into set. But normally all will be in factory setting, normal setting lah. So just now we do the settings at that setting enough already. Okay, good. Okay, now what do you do? All of you create a new project. What I want to do, because this one very simple lah. You create analog output, then you set 25 Hz, then you press the start, run forward. That's all. You press stop, they stop. Okay, start and stop, you can use this button. But forward, backward is which one? No, forward. No. I mean, running forward, backward is which one? S1 and S2, right? So which is number 4 and number 5. Output number 4 is forward, output number 5 is backward. So this is the push buttons. Okay, I will write down there. Okay, any questions before we do a simple programming? Just start, stop, start, forward run, stop. Then start backward run, stop. Then you need to do 2 scaling. One is for analog input, one is for analog output. Okay? I will write down here. Okay. As usual, we do what? The flowchart. And also, okay, it's not difficult, very easy programming. Just you need to understand first what you want to do. Okay. So input, you can see, right? Input what we have? Use the start, forward, I0.0. The first is for the time. Start, backward, I0.1. Okay. Then stop is the I0.2. Okay. Now, for this one, it's easy to press the start stop, right? Then from here, you want to test your program. Then you must go and do that, right? So what you can do, if you don't want to use the I, you can put the I also. Then you can put the DB also. It's up to you, like DB or memory means M0.0, M0.1, M0.2. It means once you download, you just use the memory, right click, modify to 1. Then you can on the mode. Then modify to 0, on and off lah. Okay, it's up to you. Then output, okay, we have the forward and backward. Forward is what number? Q0.4. Then this one is Q0.5. That's all. The other lines all we don't use. Okay. Then other than this, what we have? The analog, right? Okay. our AI for the VFD, what number? Our AI for the potentiometer, what number? 64, right? That is the first analog. Second analog, what number?
5,
6.
6.
So it's the IW66. It's your analog. The analog output? It's depends lah. Later you need to add the module. I think when you add the module by default, I think it's QW96. Right, yesterday we did one. Okay, now. So you do 2 FC now. This one is very straightforward, correct? I press start, forward must run. Stop means you need to stop. If I press start backward, this output must on. If I stop, I need to stop. That's all. This program very simple, very straightforward. Only this one is the analog. Need to do scaling. So we do 2 scaling. First is the AI VFD. So 0227648. Okay, this one is the current speed. So we convert to 0 to 50 Hertz lah. Okay. Number 2 is your, you must set point. How much yesterday, remember when you set when we set for output, measure the voltage, right? The same way. So 0 to 50 Hertz, convert to AO VFD. 0 to 2764. Okay, so you need to do 2 scaling. One is for analog output, one is for the analog input. So before you start, at the set point, you must key in the value. You must manually key in the value. Like what is the how much speed you want to run? Let's say 25 Hertz. You press 25, then you press start. Then the motor will turn. When the motor turns, at the current speed, you can get the speed value. Okay? Okay? So you totally do new project. You create in the main OB also can, or you want to create FC also can. Depends. Because very simple program, right? To what? Okay, no, you do in FC lah, one FC. So 2 scaling and 1 simple control. That's all. Okay, try this. Try that one by one. You do the first new project, create new project. You choose that model. 1212. Yes.
J4 project 1.
J4 project 1. Yeah. the signal fault. Yes, you go to this EQ. No, thank you. Yes. Oh, yes. Oh. Forward times. You want to go for your break and go for your break. Okay?
Then we have to put on PLC.
HMI only later.
Oh,
HMI. Just do the, you already add a PLC, right? Like normal program. Just add a PLC, your analog output module. Then you restart all these tagging. Then you can start to do the program.
first scaling. Jadi first kita buat yang atas dulu, scaling speed. Lepas tu kita buat add new block FC lagi sekali. Scaling untuk tu AO, BLT tu, set point tu. Yang tu tak kena masuk input ada bisik-bisik tadi. Mesti masuk yang QW tu kan. Betul tak? Rasa yang macam klik lah. Tak ingat.
control the motor. I mean, to put the frequency. I already done with the programming, the simple programming.
Okay. Scaling that.
Scaling, yes.
Okay.
But the value from the scaling, I want to connect with the frequency.
What is your address?
MW14.
14 is what? Which one? The set point.
This one is the first one. Current speed.
Can't speak because you haven't done yet.
Hmm.
So you must do this first. So set point is what address?
MW20.
So you need to key in the set point. Key in this value. How much? Any value. Let's say 25 hertz. Can you key in first?
Can I replace it?
Oh, you already haven't done. Okay, you download first.
Download first.
Yes.
Anybody using?
No.
It's not going to explode, right?
Okay, this one. Cross. For analog output, the memory must be here. This one must be there. Because the Q is 96 kan? 0 to 27,000. Okay, so it's correct. So you put any memory here. Any memory yang belum guna lagi. So if you want to know, go to PLC type and check memory apa yang available. Yes. Ini baru. Okay, ini baru. Okay. Then you go to motor control. Simple function. Alright. So that's all. Later you download. Lepas download, you go to scaling arrow. Because ni you key in dulu. Berapa speed you nak control dia. Apabila you key in, the value will go to the 96. Kan? So what happen? You akan, let's say lah, you say 25. Kan? So after, so 5 volt akan hantar pergi ke so when you press start, apabila yang ini on relay, the motor can run. When the motor running, dia akan bagi feedback that go to your analog in. The program is okay. Okay? Yes.
I forgot to put the motor in the main.
It's okay. Okay. It's okay. Oh, okay. Put interlock. That's the backward. This one. Start forward. Start backward. Stop. So you do the same thing below. And maybe next backward. Do it next backward.
I have one question.
Yes.
Help me with this. Kan the drag the
Yes.
scaling apa semua. Ada the sequence tu.
No, not necessary.
Oh, okay.
Unless bila kita call tu ada interlock dekat depan, baru dia akan follow interlock. Means like this. Macam ni kan? Unless you do something like depan tu ada macam ni kan, then this one running, then you put timer, lepas timer I create one output, then I use this output, baru dia run macam ni contoh lah kan. Like this, dia akan follow. If no, it's normal only. Because of course dia akan ada small delay. Because why? Because we know how the PLC work and how the PLC scan. Of course PLC akan scan only this. But that is in milliseconds. So not much difference. Okay. Good.
Yeah, okay.
Oh, you haven't do the memory. Okay, man. You scan first the screen.
And for me, saya guna tu, gambar dan
the result.
Oh yeah, yeah.
Okay, and ego must be here, set point. You don't use this way. This way you will be confusing. Okay, if you want to use subroutine, subroutine. If you want to use the good cleaner. What I mean, if you want to use straight away the addresses, use the all addresses. Don't use this. If you want to use this, then use only this. Can combine, no problem, but it will be confusing for you. So what you need to do, this one also you put output.
This one.
Yes. I will show you. AI input. AI input. And set point is input. Not AO. Put set point. No, change that. Set point.
This one set point.
Okay. I think you can test. Data output at AO. Enter. And current speed. Dia punya integer. Then another one, current speed. Is it on the four MS one? Yes, okay. And keep at the back.
This one.
Okay, AI. Okay, so because now ini baru the internet. Normally what we do. Here we use the address. Here we use the internet, but here use the back. So here no need. We use internet. You click new one. You click new one. You go here. Click. Okay. Temporary. Go temporary. Norm X AI. AI. Okay. The one. Real. Okay. Itu norm X AO.
This one.
Change. Norm X Y not
X.
AO. Okay. Constant take out. Now my question is, the FC you want to use subroutine or code block? Subroutine. If you want to use subroutine, the AI straight away put it here. IW64. AI here. IW64. Okay. So if you want to use subroutine, then you click here. In norm as okay, go up. Input all the all the. That's go to your scaling AO, monitor. Kalau macam ni semua, okay. Close and open. Okay, open. Now, analog output. Analog output, we must give the value. So you key in. What is the speed you want to control? 0 to 50 kan? Any number you?
Here.
Yes. Okay. So when 25, I'll do scaling separuh. Can you see? 0 to first now. 24 point something. Okay. Now, go to auto control. Very simple programming. You press that. Yes. Yes. So you hantar output and analog output through here. Then this one is the on the relay. So motor is turning. When the motor turn, dia akan bagi feedback go to your analog input. Okay, that is your AI. That is your dekat IW66. When I convert, I get around 24, 23, 25. That's what this is about. So the thing is, you try to understand. Make it smaller. So, AO ni kita kena set value. You set, macam output lah kan. Output tu kita yang on. So, we set value yang akan convert jadi analog QW96. So, ini hantar value sana. When the motor running, where we get that input kan. So, we take the input, jadikan, we convert into hertz. So, that's the difference. So, output we set. From hertz dia jadi analog. Untuk input ni analog jadi hertz. That's why difference. That's why I always tell. Untuk output memory jadi output. Untuk input ni input jadi memory. Then you stop, then you can run backward forward. Now correct. So but in this one you want to use the temporary can. Or you want to leave it this one also can. Memory no, don't use the same one because you have a different memory. This one is normax for AO. It's not right. Now go to PLC. So ya, ada tanda AO AI tu di mana? Now which memory will
16. So the next can be NW20. Using NW.
New one lah, MW how much 20 lah, 10 to 20. 20 MW 20. New one is not very easy. You put the name, current speed. Okay, good, right? You see now I want the analog understand, right? Analog is close. Now this one monitor here. Easy. Okay. Now you see I start. Oh sorry, it's not right. Now you see on this one, I on this one. Do the on. Must have a interlock. Means when I start, when it's forward running, if I press backward, backward cannot on. So I must stop first, baru boleh on backward. So now this one is now both S1 and S2 on, right? So I think they can have a confusion. Right, how to on at the one time? Yes. Yes.
This one is M20, column 3.
Very good. So what do you do? Go to now go to main. Because you do the changes right now. Okay. Yes. Because I want to use as a subroutine. Start, stop line. M0.0. Easier from here you can just make it go back. Okay. Same thing. Forward, with memory Omron. Same you can use for the manual. And you go up on start at the branch or memory start. The HMI start line. You see that which memory not being used. So start forward, stop, you take 3 memory. HMI start forward, HMI start backward, HMI stop. So if you want to test, you can test from here. Only need to go and press that. 25, right?
Supposed to be 25, right?
Yeah, 30. Check us. You got your program. What is the address for AI? IW 64, which is this one,
Oh.
not the feedback. Your feedback is 66. That's what.
Oh yeah.
Right. But the rest is okay, right? Offline, no test, you can test. Yeah. Yeah. You okay? You need to in the scaling, you need to set the set point. Okay, why? Supposed to be green color. Go to me. Scaling equals. Oh. All the block is it? Go to win. Is it the one got error, no, right? Alice, got error, any error, no, right?
Right now?
No. Okay. Okay. Yes. Now go to table. Now you set the speed. Fire. Now go to the group project. Now start forward. What you can do? Good one. Just move the lock here for this. Go up. Go for this one, got the lock.
If I on
Backward, automatically. Running off. Okay, that is. Go and check the value. AI scaling. AI. What is 24? So set 25, you get around 24. way back one. Means west. Yes, that's not. Boleh cik nak tahu this. Green there is top there. Here. No, again, it's the fan running. Yes, when forward running, you want that to run right. Put normally close here. Forward here. So means when I start forward, when the forward running, I press this, backward cannot. Same for this also. So here put the backward. Connect. Finish. Okay, go to frequency. Output as your output. This is the analog input. Speed, yeah. Okay. Monitor. Wrong. Wait. You see, MD is real, right? Correct. Real or what? The right click. The MD real wire is a real, right? Correct. MD14 real kan? So here must be real. Yes. Kalau tak dia akan ada apa? Data type conflict. Yes. Itu memang tak boleh tukar. Itu memang fix. Go to your frequency. Frequency pun sama. Okay, right click MD16 tu apa? MD16 pun salah actually. Choose real. Apa? Choose real dulu. Yes, real. MD16 tu salah sebab ini MD14 dah guna. Hence is MD18. Change MD18. Okay, change. Yes. And change this to real. Okay, go back to the speed. Check. Why so many? Kenapa? Ni dengan sana sama je. Sama. Go to frequency. IW66 convert MD14 kan? Jadi MD18 lah. Okay, go to speed. So sama. Cannot be same. So must put new one. MD22. Bukan. Right. Jangan rename, bukan rename. Padam baru. MD22. Okay. And yes, right click, rename, set point. Okay, that one change to MD26. Set speed dulu. Ini norm new to AO kan? Okay, norm X AO. Okay. Minus this. Forward tengah and balik belok. So now I want on this one memang tarik. So when I stop, then only saya boleh jadi go to backward. So backward terlalu here. So if I start forward tarik. No, ini analog betul, go back. Undo. Ini betul. Kita show you. So you see, ni input pergi ke memory, lepas tu memory convert to memory kan. Sebab ni kita punya ini nama salah. We put this is a current speaker. The naming all must be correct. If no, you'll be confused. Yang ini set point jadi analog out. Ini baru betul. Okay. Then go to show all that. Which one not using kita keluar kan? No need. This one using 20, 22, 14. Okay. Now we can download this. Okay, understand? Done, then you can just save lah. Go to your speed monitor. Go to your main. Click the main. Oh, tak ada. Kena call all this block. Dekat main tu kan. Drag and drop. Drag. Yeah. Put it. Yes. Then second one, motor controls. Drag and speed. Okay. Save down. Go to speed. No, we cannot change here. Go to speed. monitor, set the speed, set point. No, set point. Mana set point? Yes. 0. Okay, this 0. Yes. Okay, key. How much? Sudah kan 25. Okay. Now, let's start. Okay. Press can run. Release the brake. Okay. Go to motor control. Ini bukan start forward. Betul tak kan? But your backward can go. Kan? Backward can go. Bukan kepada forward. Increase the speed. Yes, kan? Lepas tu pergi tengok dekat frekuensi. Cuba check monitor. Okay, berapa speed dia? 50, right? Tadi set 50, dia also 50. Is safest. Dia take video apa dia say I want to this. So he say you want to give only cable. Say I want a cable and connector. Easier, you know only cable difficult.
Saya juga easier. Kalau kita tak ada sini kita boleh, kalau ada program kita boleh
Yes, can. I can show you. I show you simulation. Boleh. Of course lah macam kalau input value semua tu tak dapat dah. Kita manually on lah. Tengok. Macam force on, force off, I can play that.
Okay, lagi. Experience with
Yes. Mas. Same.
Okay.
Your phone?
The halfway complicated.
Yeah.
Yeah.